Hi, I'm William Malik with a bit of security for Monday, the 29th of June, 2026. Today, we're going to be talking about AI-generated code, particularly in terms of quality. When I managed the Information Security Strategies service at Gartner, I noticed that every member of the team eventually arrived at a common perspective on information security problems. It usually showed up in the form of a question. Why are there security problems? And they usually came up with one of two explanations. Either somebody made a bad decision, often because the consequences or implications of the choices were not clear, or there was a defect in the code. The issue with a person being misled by poor interface can be fixed through attention to the user interface and user experience. I strongly believe that the individual is the strongest link in an environment. And I have a tape that talks about that you can look up in this set. If your code causes someone to make a bad choice, the defect is not in them. The defect is in your code. Having set that aside, security bugs are simply a subset of code defects. And the issue of code quality is much harder. The National Academy of Sciences, Engineering, and Medicine has published two documents in the past 20 years that talk about software that can be trusted, one in 2007 and one in 2010. There have been books published on testing code. I know of two that are very good. I know over 3,000 titles that tell you how to write code. The Art of Software Testing by Glenn Myers first came out in 1979, and Boris Bietzer's book, Software System Testing and Quality Assurance, came out in 1985. So what is code quality? Philip Wyley, the author of the book Quality is Free, would simply say that quality is conformance to requirements. So high-quality code does exactly what the specification says it will do and nothing else. No side effects. If the specification is unclear, the code will be obscure. Testing, by the way, does not improve the quality of the code. All testing does is tell you how well the code matches the spec. IBM last month published a blog entitled, "What is Code Quality?" And I'm going to read a paragraph from that article. Broadly speaking, bad code is difficult to read and to maintain, brittle to changes and new features, inefficient, and unreliable. It often features unnecessary dependencies, wherein different modules are intertwined with one another, and any changes to one require extra work to avoid breaking the other. It lacks proper documentation and is poorly organized, devoid of coherent logical structure, a state of affairs often called spaghetti code. Anybody that's been programming for more than a few years knows exactly what that looks like. If you have to maintain some code that was written in a hurry by somebody who wasn't very good, you've seen it. More recently, the leak of the Mythos code segments showed that there were sequences in this leading edge product that included 250,000 calls to services that were unnecessary to accomplish the function that the code was intended to do. What do we make of AI-generated code? Of which that's an example. The ones I've studied in various languages are excessively verbose. They contain useless functions. They generate random system calls, often not even checking the result. They stitch together typical code sequences, not the best, but the most common, the average, without regard to the code's fitness for purpose or clarity of expression. With broad, vague, and generic specifications, AI-generated code will be sloppy, complicated, obscure, verbose. It'll be spaghetti code. All of these contribute to poor code quality. This kind of code is difficult to debug. The difference between average code and high-quality code can be greater than an order of magnitude in terms of defect rates. Note that fixes to code are typically an order of magnitude worse in terms of defect rates than the original code. So if you have a piece of code that has a problem and it's of mediocre quality, and you patch that problem, the odds are that you will insert a new bug for every bug that you take out. In fact, in the mid 1980s, Ed Adams wrote a technical report at IBM recommending that if a program has been working in production for a sufficiently long time, it was a bad idea to apply preventative maintenance. The thought being, if it's worked in this particular environment, although there are bugs in it, those bugs have never been exposed in that environment. And applying preventative maintenance could very well introduce a bug that will destabilize a previously functioning program. At a certain point, it becomes more efficient to throw out old buggy code and to replace it with clear, simple, fresh, new, well-designed, and properly specified code. AI cannot tell if a piece of code has any of these properties. AI cannot generate good code. It takes 5 years of work to become a competent programmer, and another 5 years of work to become a competent software architect. IBM recently announced that it is going to continue to hire trainees because these people will become the programmers and architects of the future. AI cannot do either job. A few years ago, Elon Musk made waves by dismissing many of the software development staff at Twitter, keeping only the people who had distinguished themselves by writing lots and lots of code. In other words, using volume as a substitute for quality. The correlation between code volume and defect rates is strong and has lasted for more than 60 years. The more code you write, the more bugs there are in it. AI-generated code is driving quality numbers down. And that's our bit of security for June 29th, 2026. I'm William Mallet. Be safe.